Lesson 63. Let's try it. Critical number closed interval theorem. Okay. So some various theorems, how these theorems apply to our various calc problems, and how it all comes together. So, first thing we are looking at, maximum minimum value existence theorem. In calculus, we sometimes run into existence theorems, which just shows that something exists. And for the maximum minimum value existence theorem, read and find out. If f is continuous on the interval I, which is the interval from A to B, then f attains a maximum value, m, and a minimum value, m, small m, on I. Okay, so some details. First of all, one of the conditions is that for this theorem to hold, f has to be continuous, right? It can't be broken, it has to be continuous on an interval from A to B. And so interval from A to B would be like A being the beginning and B being the end. Then this is saying that there is somewhere on there a maximum value m and somewhere on there a minimum value small m. It's just saying that they exist. And if you think about it, that makes sense, right? If it's continuous, even if it's just a straight line, there's a minimum and a maximum, right? And so it's just, as I said, it's an existence theorem. It's just saying that it exists. In this case, you can see where the maximum and minimum would be, yes? Well, oof. How does it read? There's an interesting thought. On the interval A to B, and A and B are included. So if I make A and B the endpoints, where is my maximum? My maximum is at B. And I say, oof, because I almost fell for it myself. Okay, so officially, if you're on a certain interval, B would be my maximum. And then where would be my minimum? At A. And I really should have made that M different up there, shouldn't I? Okay, so just kind of a thing to be aware of, that we have to think about these endpoints here. Okay, they can be included. Okay, unless you have questions, I'm moving on to talk about the next one. Critical number theorem. If f is a continuous function, so again, notice f has to be continuous on a closed interval I, so that means an interval where your endpoints are included, and if f attains a maximum or a minimum value at a certain point, where C is on that interval, then one of the three things is true. Okay? C could be an endpoint, like what kind of happened previously. So the maximum or minimum, what we're saying here is that that C value, where there's a maximum or minimum, it could be an endpoint. F prime of C does not exist, or F prime of C equals 0. Derivative equaling 0 is a typical way we find mins and maxes, right? When the first derivative equals 0, that's a critical point, and critical points are often mins or maxes. The first derivative not existing, those are those spots like that are not differentiable, like those hard corners instead of a soft curve, things like those. Okay, so if there's a max or a min, it could be an endpoint, derivative doesn't exist, or derivative is equal to 0. Okay. To find maximum minimum values on an interval, we have to find critical numbers and then check those and the endpoints to see which ones are the maximums and which ones are the minimums. You know, we've talked before, sometimes you just get one critical point. And if they're asking you to maximize something, we kind of fall into the trap of, oh, there's only one critical point. They want us to maximize. That's got to be it. This is going to be more the scenario of multiple critical points. Where's my min? Where's my max? Okay? So, critical numbers We have to check those and endpoints to see which ones are maximums and which ones are minimums. So look at example 1. Find the maximum and minimum values of f of x on the interval -2 to 4. Where should we start?
Take the derivative, find the critical numbers.
Yeah, we got to take the derivative to find the critical numbers. So, f prime of x, what is the derivative of that function? Derivative of 2x cubed?
6x squared.
6x squared minus derivative of 3x squared
6x.
minus 6x minus the derivative of 12x minus 12 plus the derivative of 1. 0. Now, how do we find the critical points? Set the equation equal to 0. What's something you notice about this equation? Yeah, we can factor the 6 out. Can I go ahead and do that in step 1? If I factor the 6 out, I'm going to be left with x squared minus x minus 2 equaling 0. And I went with factor 6. Daryl said factor 6. I'll be honest, that's what I have in my notes. But technically, if this is an equation equaling to 0, you could also just divide the 6 out, because we can divide both sides by 6. Okay, what do you know about that trinomial? X squared minus x minus 2 is going to factor. X squared breaks into x and x. What about numbers? X minus 2, x plus 1. I agree. Now what? Okay, set your parentheses equal to 0. And when we do that, we're going to get what? We're going to get 2 and negative 1. And what are those? Yeah, those are critical points. So, we are given critical points at 2 and negative 1. What else do we need to consider as critical points? Yeah, we are on an interval here. Because we are on an interval, negative 2 and 4, negative 2 and 4 are my endpoints. And my endpoints also count as critical points. We need to consider those. Those could be maxes or mins. So, with that in mind, that means I have critical points, critical numbers, at x equals 2, negative 1, negative 2, and positive 4. The question was, find the maximum and minimum values. How can I find the maximum and minimum values here? Yeah, take each of those 4 critical points and plug them into the original equation. So that means we have to find f of 2, f of negative 1, f of negative 2, and f of 4. Are you guys going to do the math, or should I just tell you the math? I mean, I have the values written down, so I can, you know. Do we have confidence that we could plug those in and get those figured out? Probably. That's scary. So I have the f of 2 is negative 19. F of negative 1 is 8. F of negative 2 is negative 3. And f of 4 is 33. So what do I know?
2 is the minimum, 4 is the maximum.
Okay. So let me rephrase that. The minimum value occurs at x equals 2. But what would the actual minimum value be?
19.
The negative 19.
Well, negative 2.
Okay. So there's a couple of different ways, you can say that. But the minimum value itself is technically negative 19 if they want the minimum value. It's the y value. It occurs at x equals 2. And obviously, that's the minimum because that is the lowest y value. 33 is our maximum value. The actual maximum value is 33. It occurs at x equals 4. Okay? So, was it important that we checked our endpoints? Yeah, because our max is at an endpoint, isn't it? The minimum wasn't, but our max was. So, minimum value, negative 19. Maximum value is 33. I do feel like that is something you see on AP. And I say that because I think the first year I started trying to do some of the AP practice questions, that's something I would miss. I would forget about my endpoints. And so we have to remember to look at endpoints. Okay? Questions before we try example 2? Okay. Example 2 then, when you're ready. A 10-inch long string is to be cut into 2 pieces. One of the pieces will be bent to form a square, the other piece will be formed into a circle. Find where the string, should be cut to maximize the combined area of the circle and the square. Where to begin, where to begin? Okay, we are starting with a 10-inch piece of string, correct? And at some point it is going to be cut, yes? Just making a random mark there. I need a name for these 2 pieces. Okay, I like X. But I don't want to incorporate a second variable right here unnecessarily. So if I use this piece for X, the whole string is 10. What'd you say? Then the other one can be used as 10 minus X. Okay, I know X and Y is so natural and it's so much easier in a way, but we're going to go with X and 10 minus X. Now, this was cut into what? A circle and a square. I don't think it matters which you set up where. What do we know about that length of the piece of string that forms a circle?
It will be 2 pi r.
Okay, what's 2 pi r?
Circumference.
2 pi r, circumference of a circle, which is the distance around the circle, yes? So, on the circle, circumference is 2 pi r. And so, on the circle, I use that to be x. So that means I can set up the equation 2 pi r equals x. Now, to be honest, what we're going to need, do I tell you now or later? I'll go ahead and tell you now. We're going to try and get this all in the same variable eventually. Okay, we're working towards an equation, get this all in the same variable. If I go ahead and give you the heads up now, we're going to need this solved in terms of x. So we're going to solve it for r in and put it in terms of x. And I'll pull it all together in a little bit. So if we solve this for r, what is r going to be? What did you say? I think you said backwards. Or
I said a little wrong. It would be x over 2 pi.
yeah, x divided by 2 pi. And again, this because we're going to have to work all in terms of x later. So later when I see r, I can put it in and then have an x value. Now, what about the square? Circle with c equals 2 pi r, because that's the circumference.
Do you want to keep it in terms of r?
We talk about the r in this circle we can't match with an r in this square,
Or no?
because the square doesn't have a radius.
But it's inscribed, so the length of the side would just be 2 r.
But we don't know that it's inscribed. We don't know the size of the circle in comparison to the size of the square.
Okay.
Does that make sense?
Yeah.
Okay.
I
What?
just misunderstood. When you read the problem, I just assumed it was.
So I was like, why is he?
If it
Yeah.
was inscribed, that would be right there. So twice the radius would be the side.
Twice the radius would be the diagonal of the square. Is the square inside the circle? Or are you doing it the other way
I
around?
was doing the circle inside the square.
Circle inside the square, then yes.
Okay.
Sorry. Which way are we inscribing here? Since it wasn't actually inscribed, I had to catch up with you.
Okay.
Okay, so anyways, the distance around the circle was 2 pi r. What's the distance around the square? What do we usually use there?
Or
Okay, yeah. We usually talk perimeter. For a side of a square, it is typical to say that the side of a square is s. So the distance all around the square is 4s. Now, this distance around the square is 4s. What is that in terms of the strength?
10 minus x.
10 minus x. So I'm going to set this as 4s equals 10 minus x. Again, later, if I'm going to want to work in terms of x, we're going to solve this for s. What is this when solved for s? 10 minus x over 4. Works for me. Now, what are we trying to maximize here? Area. Okay, so we need area formulas to work with. So, what do we know about area of the circle? Okay, traditional area of a circle is pi r squared. What do we know about area of a square? Area of a square is s squared. Now, combined area means we're going to put these together. But if I put these together, we've got r's and s's in the same problem. Do you see where we're going with this? I already had you solve, didn't I? So rewrite the area formulas in terms of x. So if it's pi r squared, it's pi times x over 2 pi, quantity squared. Let's see, is there any cleanup that can happen there? There's a little cleanup that could happen. So when we square this, x squares and becomes x squared. The denominator, when you square 2 pi, 4 pi squared. But what do you notice about, we have this other pi out here? And so we can take and cancel one of the pi's. And so you can think of that as x squared over 4 pi. Or what I'm actually going to write is I'm going to pull that constant out front. and say it's 1 over 4 pi times x squared. And again, I'm trying to set us up a little bit for the next step of where I'm going. Because keep in mind, if we're trying to maximize, at some point we're going to have to take the derivative. Now, are we okay with that one? We have to do the same thing for the square. It's a equals s squared, which means it's going to be 10 minus x over 4 quantity squared. Well, how about you guys can square the numerator, I'll take the denominator.
100 minus 20x plus x squared.
You took that challenge right on. Okay, 10 minus x, when you square that, you're foiling, yes? Don't just tell me 100 plus x squared. It's 100 for your first, minus 10x is going to be minus 20x plus x squared all over 16. Now we have these two area forms. We're trying to maximize, which means we're going to have to add them. So I'm going to come up here and do this. As I add them, keep in mind, we're trying to maximize, which means we're going to have to take the derivative, yes? So I'm going to set that up in the neatest way possible. Now that first formula is already pretty good. The circle, 1 over 4 pi times x squared. I'm going to write that as 1 over 4 pi times x squared. Plus. Now, if you look at the square, it's one big fraction. What can I do with that one big fraction?
Break it into 3 fractions.
Can we break it into 3 fractions? Where the denominator on all 3 is 16. And again, just trying to set us up for the next step. So I'm going to have 100 over 16, which you can write as 100 over 16, or they all divide by 4. So I'm going to say 25 over 4 minus 20x over 16. If we reduce, it's minus 5 over 4x plus x squared over 16. I'm going to write 1/16 x squared. Okay. All of that, and my job was to wrote an equation. I have an equation that for the combined area. In order to maximize, we need to take the derivative. So, derivative of 1 over 4 pi x squared. Multiply by 2. And then it's 2 over 4 pi, which 2 over 4 pi can reduce to 1 over 2 pi times x to the first. Derivative of 25 fourths is gone. Derivative of minus 5 fourths x. Minus 5 fourths. Plus derivative of 1/16 x squared. Multiply by 2 becomes 2/16 or 1/8. So 1/8 x. To maximize, we need to set our equation equal to 0. Thoughts on how to start solving this? And we are going to, in a way, combine the x terms here in a moment. I mean, you need the x's on one side, yes? So we can leave the x's on the left and combine them and move the minus 5 fourths over. So for right now, I'm just going to keep 1 over 2 pi x plus 1/8 x. And I'm going to add the 5 fourths over to the other side. What kind of common denominator do 2 pi and 8 have? 8 pi. So let's rewrite these with a common denominator. If I have a common denominator of 8 pi, multiply that first fraction by 4, and so it's 4 over 8 pi x, plus the second fraction I'm going to multiply by pi to get a denominator of 8 pi. You see that? I can zoom in more so you guys can see what I'm working on there. So I have 4 over 8 pi x plus pi over 8 pi x equals 5/4. Easiest way to multiply or to add these together, think in terms more of a factoring step. Can we factor an x out? Okay, I kind of think of it as that way, or you're adding them. The key is denominator of 8 pi on top. What is 4 plus pi? Yeah, so I'm going to write it as 4 plus pi over 8 pi, and then times x. How do I solve for x?
Multiply by 8 pi over 4 plus pi.
Okay, multiply by the reciprocal. We have this fraction times x to get x by itself. We're going to multiply the 5/4 times 8 pi over 4 plus pi. I think at that point, it becomes a decimal. Okay, I have a decimal, I'm trying to think. Yeah, I did a decimal. It's not that you'd have to use a decimal, but keep in mind, if we're plugging this back in later, a decimal's easier. So, did you get a decimal, Daryl?
4.399.
Yep. I have written down 4.3990. What is this 4.3990? It is a critical point. Now, what are all of my critical points? The whole point of the lesson today is you have to remember those endpoints, don't you? Okay, so what we need to think, critical points at x equals 0, 10, and the 4.399 number. So, in order to find the maximized area, we're going to have to plug those values in. Use that original function. You need to find a of 0, a of 4.3990, and a of 10. Do you guess it's going to be the 0? Well,
maybe that's 10. I don't
no,
know.
it's 0. So if we plug in 0, you can see that you end up with 25/4, which if you change that to decimal for comparison's sake, it's 6.25. I have written down that when you plug in 4.399, you get 3.5006. And I have written down that when you plug in 10, you get 7.9577. Oh, wait, no, I didn't. Okay. Where's my max happening? Because we're trying to maximize. Where's the max? At 10. Now, and here's what you have to look at. Okay? Think about the way we drew the picture. And this is where it does matter when you get to the end. We have to go back and look which way we drew the picture. It says a of 10. So when x is 10. So when x is 10, What's that saying? The whole thing is the circle. Okay? So, where do I cut the string? You don't cut the string. In order to maximize the area, you make it all circle. So,
I don't like that at all.
all that work for that answer?
There was no square.
No one ever likes the results of this problem, I will say, and I don't blame you.
It says one of the pieces will be bent to form a square.
But it's the piece that's a going to clear up.
But I don't like that.
Okay, so I'm writing at 10 inches should not cut the string. Use for circle. That is the note I wrote down there. I know you probably can't read it, but that is what I wrote. At 10 inches, you should not cut the string. You should use it for the circle. The reaction I usually get is, wait, we did all that work to find out we're not going to cut the string. But notice, I mean, you have to think about the day. The day is we're talking about endpoints, right? And how your endpoints could be a maximum or minimum value. Well, 2 of my 3 critical values were endpoints. So you have to realize we had a pretty good chance of one of the endpoints being the maximum. Okay, on the back side. Forgot this is a long lesson. Sample 3. Find the maximum and minimum values of f on the interval -2 to 3, where f of x equals x to the 2/3. Okay. So, where do we start? Okay, we've got to find f prime. So if f of x is x to the 2/3, what's f prime of x? 2. I really don't like the way I wrote that. I made it way too big. And that's going to bug me. So I'm going to fix it. Try again. So I did agree that it was 2/3 x to the -1/3. And how do we find these critical points? We're going to set this equal to 0. Now, as I set this equal to 0, I'm going to put it in a different form. What do you know about that x to the -1/3? Okay, it's 1 over the cube root of x. If we do the 2/3 in there with it, the 2 is going to stay on top, 3 in the denominator. So what if I say this is 2 over 3 times the cube root of x? When does 2 over 3 times the cube root of x equal 0? When does a fraction equal 0? When the top equals 0. What is my top? 2. When does this fraction equal 0? It doesn't. Okay. Now, what's the catch in the bottom? What can you not put in that denominator? Like, what value for x cannot go in the denominator? 0, because 0 cannot be in the, it makes the fraction undefined, right? So this fraction's never going to equal 0. However, what we do know is that f prime of 0 does not exist. Okay, so even though our derivative will never equal 0, and so we don't get a value that way, we do know, because x is in the denominator, that our derivative, x equals 0, cannot work. Okay, and remember, if we talked in the front, in our critical number theorem, C could be an endpoint, f prime could equal 0, or f prime does not exist. This is where f prime does not exist. The derivative does not exist when the denominator is 0. So, what are the values I have to try here? -2, 3, and 0. Okay, so we're going to have to find f of 0, f of negative, and f of 3. Zero. Logan's favorite number today, I guess. Okay, what's f of -2? I have written down 1.5874. And f of 3, I have written down 2. What were we being asked to do? Maximum and minimum values are where or what? Okay. 2.0801 is my max because it's the largest y value. And 0 is my min because it is the smallest, it provides the smallest y value. So, my minimum value is 0. My maximum value is the 2.0801. Again, remember for max and min values to give me the y values. Okay, get what you need there. We've got one more example, example 4. Okay, a function f is continuous on the closed interval -2 to 4. Also, they tell us f of -2 is 2, f of -1 is -1, and f of 4 is 5. Furthermore, the function f prime and f double prime have the properties indicated in the table below. That's why I have it handwritten in. And the part that you're missing that's kind of important is what are we doing here? Which I was like, what? Okay, our goal is to find the values of x for which f attains max and min values. I will put that right here. Find the values of x for which f attains max and min values. That's the other part that's helpful to know. Okay.
X equals -1, x equals 2, are going to be critical points.
Yeah. Okay, so let's see. It's continuous on the closed interval -2 to 4. They also tell us that f of -2 is 2. So I'm going to put this down here, kind of just organizing. If f of -2 equals 2, what ordered pair is that? Realize they're giving you the ordered pair of -2, 2, because I plan for us to do a sketch here in a moment. Okay. They also give us an ordered pair f of -1 equals -1. I'm going to put that here above the x equals -1. And so what is that? The ordered pair of -1, -1. And f of 4 is 5. Is going to be my right-hand endpoint of 4, 5. Now, notice the top row is my first derivative. well, the top row, I guess, is the various x values. F prime of x. What does the first derivative tell us? Yeah, so like here, when it says f prime is negative here, what is that meaning? Okay, it's going down, it is decreasing. Okay, so from negative 2 to, that's not supposed to be negative 2, negative 2, that doesn't make sense. Negative 2 to negative 1. Yikes. I just had to get to the point where I was actually reading it and not just going off of what I remember about this problem. Okay, so a negative first derivative means the graph will be decreasing. Undefined, as you mentioned, it's probably some kind of critical point. Okay? Right, when the derivative is undefined, right, it's not going to, the derivative does not exist. Okay, which, if the derivative does not exist, we're looking more at like a hard, sharp point. Okay, as opposed to, you know, so what we do know here, since this derivative is undefined, some type of what usually is called a hard point, but it goes and makes a point, which you can't take the derivative at that point. In the next interval, we have a positive derivative, and so my graph will be going back up. X equals 2, that means it's going to be some type of critical point. We'll come back and talk about that in a moment. And then from 2 to 4, it's also positive. So that means my graph is increasing. Now, what does second derivative tell me? Concavity. A negative second derivative means it is concave down. Okay? Undefined. We already talked about that being a hard point. Another negative second derivative is concave down. And then the last one, it's positive second derivative, so concave up. And then this second derivative equaling 0 here, what's that going to end up being? An inflection point, right? Because when the first derivative equals 0, usually min or max, but we say min, max, or inflection point. When the second derivative equals 0, that's when we're going to talk inflection point. Okay, let's attempt this graph. I'll give you a visual here. Okay, I know I need to, what? Have to count left 2 and right 4. We have to be able to go up as high as 5 and as low as -1. And that's just using the gathered given information. Okay. We have a point at -2, 2. We were given that point. We were also given a point at -1, -1, left 1, down 1. And we are given a point at 4, 5. Okay. Now, in all honesty, based on those points, you probably have an idea of where my max and min values are going to be. But let's also practice. So from -2 to -1, what's my graph doing? It's decreasing, which going down, which makes sense, right? It better be decreasing, or I don't know how to do this. And concave down, which means it's bold down, so to speak. And so what it means kind of looks like that. Does that make sense? It's a hard spot to make it bold, like bold concave down like that, but that's what we're doing. Okay, -1, we already talked, hard point, got that. -1 to 2. What are we doing? We are increasing and concave down. So we're going to increase. but it's going to be concave down. So it's going to be shaped down. Now, I don't have a y value at 2, so it can just land wherever. And then what happens from 2 to 4? Yeah, it's increasing still, but flips concavity. So now, instead of being concave down, it's going to be concave up. That is not my best attempt at this drawing, but you see the pieces. Now this reads, find the values of x for which f attains max and min values. Where does my minimum happen? At x equals -1. Where does my maximum happen? At x equals 4. Okay? And I know we could have done some of that without drawing all the graph and everything. However, man, it's good to be able to put all those details together because that's a lot of details to put together. So I like to be able to go through that with you at points and talk through it. Okay? Okay, your guys' job is lesson 63.